It's 4.5. We're exploring graphs of the reciprocal trigonometric functions. So we looked at sine, cosine, and tangent functions. Now we're going to look at cosecant, secant, and cotangent functions, okay? So question number 1 says, here's a graph of y equals sine of x. Use this graph to predict where each of the following characteristics of the graph of y equals cosecant of x will occur. Well, before we do that, I want to actually do the graph of y equals cosecant of x because right here, we know how to graph reciprocal functions based on our original functions. And we know that cosecant of x is going to be 1 over sine of x. So I'm going to go ahead and graph out, even though we have it here, I'm going to graph out my sine function first. And I'm going to put 1 here, and I'm going to put -1 here. And I know that my sine function, sine of 0 is 0 based on my unit circle. At pi over 2, sine is 1. At pi, it's 0. At 3 pi over 2, sine is -1. And at 2 pi, it's 0. And then I can just work backwards with my curve that I have here. So I know that this is what my sine function is going to look like. Now, why is this sine function going to be useful for me? Well, when I do my reciprocal function, I know the characteristics of my sine function. I can use them to help me figure out the characteristics of my cosecant function. So first of all, I see that I have some zeros at these values over here. So at multiples of pi, I have zeros. Well, if I have zeros at multiples of pi, that means that my reciprocal function will have asymptotes there, because remember, wherever my zeros are, my reciprocal functions will have asymptotes because the reciprocal of 0 is going to be undefined. So I know that in my graph right here that I will have a asymptote at pi, an asymptote at 2 pi, another asymptote at 0, another asymptote at -pi, and another asymptote at -2 pi. And that would continue going in either direction that I'm going here. Okay? I also know that I have a value of 1 when pi over 2, when x is pi over 2. Well, the reciprocal of 1 is going to be 1. So I know that my new graph is going to also have a point at 1. And the reciprocal of -1 is -1. So I know my new graph will have a point here. Same with this example right here, as well as at -3 pi over 2. Okay? So now I want to know, well, what's happening exactly? When I look at my sine function from -2 pi to 3 pi, from -2 pi to -3 pi over 2, my graph is increasing and positive. Therefore, the graph of my reciprocal function will be decreasing and positive. So then that means that I know that my graph will look like this. Okay? Then, once I hit -3 pi over 2, they meet. And then after that, my graph is going to be decreasing and positive. Remember, the reciprocal function, if the original function is decreasing, my new function will increase, but whether they're positive or negative stays the same. So this means that this is going to be positive and increasing. So that's the first part of my graph that I have here. Okay? Now I know from -pi to -pi over 2, my graph is negative. Therefore, my reciprocal function will also be negative. And from -pi to -pi over 2, my graph is decreasing, so my reciprocal function will be increasing. Okay? And then from -pi over 2 to 0, my graph is negative, so my new graph will also be negative. But from -pi over 2 to 0, my graph is increasing, so therefore my reciprocal function will be decreasing. Okay? All right, from 0 to pi over 2, my graph is increasing, so my reciprocal function will be decreasing. My original graph is positive, so my new graph will also be positive. So this is what my graph will look like. They meet at pi over 2, 1. Okay? And then afterwards, my graph stays positive, so it'll stay above the x-axis. But since this is decreasing, this will be increasing. Okay? And then the same idea is happening here. Since this is negative and decreasing, my new function will be negative and increasing. Since this is negative and increasing, my new function will be negative and decreasing. So in pink, we have right here that this is y equals sine of x. And then in orange, we have right here that this is y equals cosecant of x, or just 1 over sine of x. Okay? It asks us to verify with decimals, so we will do that right now. So first of all, our graph in Desmo, or sorry, our graph in our paper is going from negative 2 pi to 2 pi. So I'm going to go from negative 2 pi until 2 pi. And it's going up by pi over 4. So we are going to also go up in steps of pi over 4. So we'll say right here that this is pi over 4. And then our y-axis is going from negative 4 to 4. So we'll say negative 4 to 4 with a step of 1. So that way we have an idea of what's happening in our graph right here. So now it looks like what we have on our paper right here. So the first thing that we graphed was y equals sine of x, and when I look at it, this is exactly what we got, okay? Now let's go ahead and do y equals, and then if I go to my functions, I will find the cosecant of x. We'll do y equals the cosecant of x, and that's exactly what we ended up getting. We had our asymptotes at x equals negative 2 pi. All right, we also had another asymptote at x equals negative pi. So there we go. We can see that there's an asymptote there for sure. We had another asymptote at x equals 0. We had another asymptote at x equals pi, so on and so forth. So we can see all of our different asymptotes. So definitely this blue graph right here is going to be the graph of our cosecant function. So I'm just going to turn everything else off so you can see that essentially just this blue graph right here is what our cosecant function is going to end up looking like. Okay? With regards to this chart right here for number 1, we're just going to not worry about this for right now. We'll talk about it probably during class a little bit, but it's not that important. What's most important is figuring out if we understand where this information is coming from and how to do our actual graphs, okay? So now we're going to skip number 3. We're going to go to number 4. It says use your predictions to sketch the graph of y equals secant x. Instead, I'm going to use the graph of y equals cosine x to do my sketch. So I know y equals cosine x is going to be my original function, and then my reciprocal function is going to be y equals 1 over cosine x, which is secant x, right? So we'll say right here y equals 1 over cosine x, which is, sorry, the x needs to go to the cosine, which is the same thing as the secant of x. All right, so same thing, I'm going to just go up by ones right here. So 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. I know that the cosine of 0 is going to be 1 because when I look at my unit circle, the x value is 1. I know that the cosine of pi over 2 is going to be 0. I know that the cosine of pi is going to be negative 1. The cosine of 3 pi over 2 is 0, and the cosine of pi is 1. And then I can just go ahead and work backwards for the other half of my graph right here. So I know that this is what my graph is going to look like for cosine of x. Well, I'm going to use this graph to help me out when I do my graph for the secant of x. Okay, so you want to make it look as much like the cosine function as possible, clearly not like what I'm doing right now. So this is what we've got going on, and we've got arrows on both ends. By the way, I don't know if I put arrows on both ends for my sine function. I don't think I did, so make sure you add that in there. Okay, so now that I've done that, the next thing I need to do is identify some key pieces of information in my secant of x function. So the first thing is where are my zeros of my original function? Well, my zeros occur at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2, so on and so forth. Therefore, my asymptotes will also occur there for my secant of x function. So I'm going to go ahead and graph out where my asymptotes are going to be. So here are my asymptotes. So they're a little bit off from where we had our asymptotes for our cosecant function. They're shifted, but remember, sine and cosine are basically the same function, just with a horizontal shift. We also know that right here, when x is 0, we have y is 1. Well, the reciprocal of 1 is just 1, so I can just say that this is 1 right here. The reciprocal of negative 1 is negative 1, right? So I can just keep going with this right here. So I know that these blue dots right here, these blue coordinates, are going to be values in my graph. And I'm going to apply the same idea that we did for sine to figure out cosecant as I am to cosine to figure out secant. So I'm going to look at this section right here first. So in this section, my graph is decreasing and negative. Well, if it's negative, then my reciprocal function will also be negative. But if this is decreasing, then this will be increasing. So this is going to be increasing until I get to this point right here, until I get to where they intersect with each other. Then my graph will start to increase. My original graph will start to increase, so my new graph will start to decrease. But since it's negative originally, the new function will stay negative. Okay. Over here on this in this section right here, my graph is now positive, so my new graph will be positive. It's increasing, so my new graph will be decreasing. Okay. Over here it's positive, so my new graph will still be positive. Here, since this is decreasing, this will be increasing. So it will look as follows. And the same idea continues right here. So my purple function is going to be y equals cosine of x. Therefore, my blue function right here is the reciprocal of cosine, or just secant of x. So I'm going to graph out y equals cosine of x, and I'm going to see that it looks as follows, right? So this is nothing new for us. But now I'm going to graph out y equals secant of x. And if you notice, this is exactly what we ended up getting right here with our vertical asymptotes occurring at x equals negative 3 pi over 2. Right? Also, we've got an asymptote occurring at x equals pi over 2. We've got another one occurring at x equals negative pi over 2. And another one at x equals 3 pi over 2. And then it just keeps going for us as our cycles continue, okay? But really, essentially, the most important piece is the actual secant function, which we now know looks as follows, okay? Okay, so we're going to skip number 5 for now, and we're going to go ahead and take a look at number 6. Number 6 asks us to use our predictions to sketch the graph of y equals cotangent of x. We're not going to use our predictions. We're going to actually use y equals tangent of x right here to help us out. Okay, now first thing I want to do is talk about the unit circle really quickly. So we know that this is 0, we know this is pi over 2, we know that this is pi, and we know that this is 3 pi over 2, okay? And we also know that when we are figuring out tangent is going to be equal to y over x. So our y coordinate divided by our x coordinate right here. So when we have the tangent of 0 right here, when I want to do the tangent of 0, I'm going to take my y value and divide it by my x value. So it's going to be 0 divided by 1, which is 0. So I know that 0 right here is going to be one of my values for tangent of x. That's all we're focusing on right now, okay? Now, for pi over 2 right here, this coordinate is 1, 0. Excuse me, sorry, is 0, 1. So when I do my graph, I'm going to divide 1 by 0, which is undefined, which means that I know I'm going to have a vertical asymptote at pi over 2. Okay, now where is it going to be the same? Remember, at pi over 4, the x and the y values are exactly the same. So we know that at pi over 4, let me number these axes for a second. We know that at pi over 4, right here, we have a 1. And at negative pi over 4, we'll have a negative 1. Okay, so this is just review from what we did before. And that will have a vertical asymptote that will occur at pi over 2 right here. So I'm going to go ahead and graph in my vertical asymptote so you guys can see that we'll have a vertical asymptote here. We'll have another one at 3 pi over 2. We'll have another one at negative pi over 2, so on and so forth. Remember, this is just the original function. We haven't looked at the reciprocal function yet, okay? So I'm going to go ahead and continue graphing out my original function. So, and this cycle continues to repeat itself, right? So we've got negative 1, 0, 1. So we've got this. It's going to look like this as follows. Okay, and then we've got negative 1, 0. So this is what our graph is going to look like right here for the original tangent function. We haven't gotten, I'm going to say this one more time, we have not gotten to cotangent quite yet. Okay, so we know that this is y equals tangent of x. Now, let's go ahead and apply our information to cotangent of x. Okay, so for cotangent of x, we know that we're going to have asymptotes that are going to be occurring where we have our zeros right here. Okay, so I'm going to actually take all of these asymptotes right here and I'm going to get rid of them. So I'm going to delete this asymptote right here, this one right here, because this is not the asymptote of my cotangent function. So remember, cotangent right here, I will do this in blue, cotangent is 1 over tangent right here. Okay, so we know that we're going to have our asymptotes occurring where the zeros are for my original function. So we know we'll have an asymptote here, we'll have another asymptote here. So at 0, at pi, at 2 pi, at negative pi, and at negative 2 pi. Okay, we also know that our graph over here, our original graph had an asymptote at negative 3 pi over 2. So therefore the inverse of undefined is going to, the reciprocal of undefined is going to be 0. So if there was an asymptote here in the original function, then there's going to be a 0 in the reciprocal function because it works both ways. We had an asymptote here, so we'll have a 0 on the reciprocal function. The original function had an asymptote here, so we'll have a 0 on the reciprocal function. The original function had an asymptote here, so we'll have a 0 at our reciprocal function here. Okay, now we also know that this graph right here has a y value of 1. The reciprocal of 1 is 1. Over here, the y value is negative 1. The reciprocal of negative 1 is negative 1. So I can keep going with this, and these are going to be these blue dots are going to be my new points of my graph. So again, I'm just going over where we have 1 and negative 1 because the reciprocals of those values stay the same. So therefore, this is what my graph right here will end up looking like. So it looks just like our tangent graph, except it's just going in the opposite direction, okay? As well as the fact that our vertical asymptotes and our zeros are switching with each other. So our blue is going to be y equals cotangent of x. Now let's verify to make sure that this makes sense. So at pi over 4, when I do, so if tan is y over x, then cotangent is going to be x over y. So if y over x is 1, then x over y is still going to be 1, right? So it doesn't really change anything here. Now here, instead of doing 0 divided by 1, I would do 1 divided by 0, which is undefined, which is why I get a vertical asymptote at x equals 0. So again, they're going to switch with each other. Vertical asymptotes will switch with our zeros, zeros will switch with our vertical asymptotes. So let's go ahead and graph out y equals cotangent of x. So we'll say y equals, and then we'll go to our functions, and we will look for cotangent of x and graph it out, and there we go. We've got it looking exactly like what we have in our graph right here. Okay? All right, so next we're going to look at predict what will happen if the period of cosecant of x changes from 2 pi to pi. So let's see right here. So my period right here was 2 pi. I needed 2 full pi to get a full cycle. Well, if it changes from 2 pi to pi, that means that it's just going to do the work or complete the cycle in half the time, right? So let's just verify to see if this is true on Desmos. So let's go ahead and do that right here. We've got cosecant of x. So we'll put functions right here. We'll say cosecant of x right here. And then if our period switches from 2 pi to pi, that means that we can say right here, this is good practice right here, so our period is equal to 2 pi over k, right? So we went from pi to 2 pi, from 2 pi to pi, so we can say pi equals 2 pi over k. multiply both sides by k, we get pi k equals 2 pi, which means that k is equal to 2. So we can use y equals cosecant of 2x. And let's go ahead and write that in and see what we end up getting right here. So in a new function, I'm going to say y is equal to function cosecant of 2x. And I can see that it's much less spread out. It's skinnier, and I'm completing 2 cycles when I would normally complete 1. Okay, so write an answer down right here, and then we'll discuss what your answer is next time I see you guys in class. All right, the last question, number 8. Do the primary trigonometric functions and the reciprocal functions have the same kind of relationship that linear and quadratic functions and the reciprocal functions have? Absolutely yes, right? They definitely will. So what are some things that are happening? Well, when the original function has zeros, the reciprocal function will have asymptotes. Okay? All right, so that's key, and that's true vice versa. When the original function has asymptotes, the reciprocal function will have zeros. Another key piece of information that we used to do this was when the original function is positive, the reciprocal function is also positive. When the original function is negative, the reciprocal function is also negative. Okay, and then one last thing that we use to help us graph out our information is that when the original function is increasing, remember the reciprocal function is going to do the opposite, and it's going to be decreasing, and vice versa. So when the original function is decreasing, the reciprocal function is going to be increasing. Okay, so everything is true no matter what type of function the original function is. The reciprocal function will always follow these important rules right here. Okay, all right, I'll see you next class. Have a great day.